Right. I am hoping that you can see me and hear me. I had to kind of redo how I was getting the live started. So again, hopefully you can see me and hear me. All right, give me just a moment. All right, there we go. It took a minute for my chat to finally pop up. I don't know what took that so long for that delay, but all right, let me just get this situated. And then I'll be ready to kind of answer any questions that you might have. If you're here, go ahead, type that in the chat. If you have questions, let me know if you're having difficulty seeing and or hearing. It's a little hard for me to judge if things are coming across just fine. Okay. All right, I'm just gonna look a little bit at this, waiting to see if anyone ends up having any questions. So feel free to jump in, chime in, tell me if you can't see or hear, give any feedback. Absolutely welcome to that. I'm using my new laptop, so I literally just arrived a few days ago, so I'm still working out some kinks there. Okay, so this is the exam from Friday, June 16th. If we look quickly, this was the conversion chart. So what does that mean? That meant in order to pass with a 65%, you needed to earn 50 out of those 85 points. Okay. At the top of the scale, you are going to get a little bit penalized. You're not going to get an exact percent score. Your score is actually going to be a little bit less for the most part than your percent. That'll get boosted up closer to the bottom. But then there is the annoyance of some double scores. You can see where two raw scores, so both 54 and 55, are going to equal 68%. So although there are none of those at the top, so I guess that is a positive, until we get to a score of 75, and then we have a duplicate. So there are no duplicates up here, but your percent doesn't necessarily match with your scaled score. So for example, an 84 out of 85 is really a 99%, but your scaled score is going to be a 98. So it doesn't matter what the percent is, you're going to earn the scaled score. Okay. And obviously you used the reference table for this exam. And there were 50 multiple choice questions and then 35 additional questions where you had to write some type of response, and that those would have gone in the answer booklet. So space for longer answers, space for most of the time showing a numerical setup, but it could be to draw like a Lewis dot structure, spots for short answers, okay, and more short answers. And then sometimes you'll notice, like right here, this is obviously a spot where you had to do a calculation, and there's a spot with a unit already given. So you don't actually have to remember units. And then we have a balancing one. This is probably one of the toughest balancing equation questions that I've seen on an exam in a very long time. So, I did not write it, but I definitely can feel some frustration with some people with that exam. Okay, because with this question in particular, because it definitely was more difficult than previous exams as far as balancing question. So that's just the general setup of the exam. And when we go back and look at the actual exam, for the most part, the questions are pretty fair. Okay. Some sort of weird questions, at least that are sort of unusual for this exam. Let me focus on some of those as I'm just waiting for if any questions pop up. So again, if you have a question, feel free to just throw it out there in the chat. Let's see, this question right here, although it is a fair question based on table I, this definitely was a little bit more perhaps than usual for a part A question. So what you had to do is go to table I. Once you are on table I, you had to find the correct equation, which conveniently that one was listed right there. So that was easy enough. You had to see this, either remember or look down here. So yes, this is exothermic. And then remember what side of the equation exothermic goes on. So that was kind of a lot for a part A question, although it is still fair. And then you also had to make sure that the coefficients matched up. So there's a 2 in front of both oxygen and water. Okay, so that was a little bit much for a part A question, but still a relatively fair question. Let's see, this one is pretty common. Again, looking at electrons between oxygens in an O2 molecule. The ones that they're often asking, anything that's a Brinkelhoff or O2 or N2. Okay, so those are pretty common. This is okay. Let's see, where was the other question? Um, that I was thinking was, see, those are all really fair questions. And this, this is just a definition, remembering low boiling point is weak intermolecular forces. Isomer definition, that's super common. You should be expecting that. They did have a pH, right? Remembering that moving one number on the pH, so for example, from 7 to 6, is a 10 times change in the hydronium. And you just had to know that increasing moves this way closer to 0. Okay. This is fair. This was just remembering that phrase, which is red cat, so reduction at the cathode. These are relatively easy. So again, to be fair, part A, relatively decent. I don't have too many big complaints about A. Okay. I do not like 32, how it's set up. Now, oh yeah, as soon as I get there, absolutely. So I'll tell you why I don't like 32, because normally you have to think about changing the percent into a decimal. So it's going to be 0.518 and 0.482. But neither of these setups involved changing the percent into a decimal, but two of them left it as a percent. So what you had to remember is that you definitely can't use this number as it is, okay, because it is a percent. So these two are definitely wrong. What you had to look at is that, well, if it's a percent, that means you have to change it into a decimal. So again, I don't really like the way that this one is asked and set up in particular, but this would be the correct answer because it's the correct atomic mass with the correct percent. Okay. And then these ones are relatively straightforward. I can go straight to 45 now. Most of these are pretty straightforward. If someone has a question, I can definitely, go back to a question up here. All right, so number 45, given the formula representing a compound, what is a chemical name of this compound? All right, so what I'm going to do is use the answers to help me at first. Okay, so you can see they all end with pentane. So that means that part is not going to help me get to the right answer. But what does it tell me? Well, pent, if we go to the reference tables and look at P, pent means 5 carbons. So what that means is I have right here 1, 2, 3, 4, 5 carbons. Okay, again, but that's not helping me get to the name yet. All right. Then what else do I have? Well, all of these say dibromo, dibromo, dibromo. And then they have 2 numbers, right? Now I can see the numbers are what's different. So what does dibromo mean? Well, di means 2. And that's not on the reference table. That's you have to kind of pull that one out of your head. So if I go to table R, okay, I can see that right here is bromo. And bromo means there is a Br attached. So I have some carbons and I have a Br attached to it. The di means I have 2 bromos, okay, attached. So what I'm going to want to do is think about numbering this carbon chain. Okay, so I can number it going forward. So this would be 1, 2, 3, 4, and 5. Or I could number it in reverse. So this carbon would be 1, then 2, then 3, then 4, and then lastly 5. Okay, so either I number it going this way, 1, 2, 3, 4, 5, or I number it going this way, 1, 2, 3, 4, 5. So what I need to do is look where those bromos are attached. Well, they're attached to this carbon right here and this carbon right here. So that means the address tells you the location of the bromo. So one bromine is attached to carbon either number 1 or number 5. And this bromine is attached either to carbon number 2 or carbon number 4. So what I need to do is use the lowest set of numbers. Okay, so I would either use 1 and 2 or 4 and 5. And since 1 and 2 is the lower set, I am going to use those 1 and 2. Now, I can tell right away if I look at the answers that the first two where it says 1, 1, what does that mean? That means I have one bromine attached to carbon number 1 and then another bromine attached to carbon number 1. So it would look like this. So let's just say this is the beginning. This is carbon number 1. And I would have 2 bromines attached to it. A bromine attached to carbon 1 and a bromine attached to carbon 1. And that's definitely not what it looks like as far as for the structural formula they give me here. Okay. I hope that helps explain it. Okay. Let me see. There was another question. Number 44 was a little bit, kind of involved for this one. Oh, you're welcome. And just because it told you each one of these lines is 100 kilojoules, so that's 100, then 200, then 300, then 400. And you had to remember, well, first, if it's endothermic or exothermic, well, since it starts low and ends high, it is endothermic. And endothermic always have a positive heat of reaction. Okay, so in actuality, I didn't need the 100 because they didn't check my math. All right, as long as I remembered endothermic and endothermic was positive, which I could have gotten from table I. This one, number 40, it's a fair question, but it did test to see if you knew or remembered that xenon is a noble gas right here, and noble gases are monatomic. So remember the ones that are diatomic are Brinkelhoff, Brinchlhof. But xenon is a noble gas, so it is monatomic. So it needed to be a gas and only one atom. It should not be bonded as diatomic. Okay. And then let's see. This kind of an unusual question, but relatively fair. You had to notice that there was a battery. What does a battery mean? A battery means it is electrolytic. And one of the types of chemical reactions that it can happen in an electrolytic cell is electrolysis. Or it could be electroplating, but it's going to literally start with something electro. This one is just testing about concentration. And that's pretty straightforward, but it also tested, did you know that covalent compounds do not conduct electricity? So these two are not conductors. How do I know? So I know covalent do not conduct and conduct, and covalent is all non-metals. So I can tell that carbon, hydrogen, and oxygen are all non-metals, so they're covalent. So they already don't conduct electricity. So then it's just deciding between these two, and I'm going to pick the higher concentration, the bigger number. And number 50 was such a weird way to ask this question. It's testing, do you know this fact that mass is converted to energy in nuclear reactions? So this is why nuclear reactions are so good at producing energy, because in fact some of the mass is converted into energy. But what you needed to do here is figure out how much mass. Okay. So you had to add these two numbers together, these two right here. And then on this side, you had to multiply this. So let me pull up a calculator so that you can see what I mean. So what you had to do was 6.0151 plus 2.0140 equals this. So that's how much mass. So I'll copy it and put it over here. That's how much mass was on the reactant side. Okay. Then on the product side, we had 2 times 4.0026. We had this much. Okay. Are those two numbers the same? Nope, they're not. So how do I figure out how much of the mass was converted into energy? You're just going to subtract those two numbers. And it's a really small number. Once you get those two numbers there, you should realize that that's pretty small. And when you subtract them, you're going to get that. Okay. And this right here, number 48, that's a traditional kind of half-life question. Hopefully that makes sense. That's pretty common for how they ask those questions. Let's see. This is a repeat, really common question. Definition of isotopes, super common. This is a combined gas law question. Here, though, which is super common with combined gas law, they tell you it's STP. So you have to remember that you have to go back to the front of the reference table where STP values are listed and get them from there. Otherwise, you don't get any pressure and volume. Like, you don't have enough numbers to do the calculations. All right, so you have to remember to look there. This one, number 54. Oh, I'll tell you this. One of my teacher friends said that they like to think about ideal gas, okay, like tropical vacations. Okay, so think about ideal vacation. Ideal vacation for someone might be a tropical vacation, but ideal gases, they literally love tropical vacations. All right, so what does that mean? Well, a tropical vacation has high temperatures and low stress, right? Not a lot of stress going on. We'll call stress pressure. So that means when something is behaving like an ideal gas, it has high temperature and low pressure. So if I wanted to behave more like an ideal gas in terms of pressure, what do I want to do with the pressure? Decrease it, right? Okay. Let's see. This one, okay. So heat flow. I don't know why people want to make a heat flow question really difficult. When it says state the direction of heat flow, they do not mean say left or right or north or south. No. And you don't want to say heat rises because that's not always true. Heat goes from warmer to colder. So if I had a heater above my head like this, heat would flow from warmer to colder. So although in general, that's often the way it goes, do not write heat rises. Do not write left, right, up, down, any variation of that. You should write, when they ask you for the direction of heat flow, they mean from what object to what object. So if I take my hands and put it on this laptop and it feels cold, that means my body temperature is higher than my laptop. And heat will flow as soon as we're touching, and it will flow between me and the laptop, from me to the laptop. Okay. Also, my body temperature is warmer than the air around me, and the air is touching me. So heat will flow from me to the air. Okay, so it said the direction of heat flow between the candle flame and the beaker of water. Well, the candle flame is warmer, it has a higher temperature. So it will flow from the candle flame to the beaker of water, from the candle to the beaker. That's fine. Shorten it a little bit. But so it would go from the candle to the beaker, or something along those lines. We read some hot mess of answers for that question. Okay. That one was relatively okay. You just had to make sure that you picked the heat formula that involved a change in temperature. So you needed to use this formula. And state how the molecular motion of the water molecules. This one also, I don't know why, but there were so many weird answers for this question. So, how the molecular motion of the water molecules in the beaker changes as temperature increases. So, temperature is average kinetic energy, right? Kinetic energy is energy of motion. Oops. Okay, so particles at high temperature move faster. Particles at low temperature move slower. So, how does the molecular motion of the water molecules change as the temperature increases? They move faster. The molecules move faster. Okay. Let's see. This one, I don't know why you all forgot about equilibrium, but at least a lot of people I graded. So rate at equilibrium, rates are equal. Concentrations are constant. What did they ask about? Rate. So at equilibrium, the rates are what? Equal. That is what you should have had. Your answer should have been rates are equal. Okay. And how the equilibrium shifts when pressure is increased. Okay, now to be fair, this was probably one of the harder questions they could ask about Le Chatelier's principle, so I'll give you that. Okay. So what you need to do is compare the two sides of the equation and look for gases. So gas, gas. I don't care about which elements. I don't care about subscripts. What matters is the coefficient. And if you look at this coefficient, it's 2. So I have 2 moles of gas over here. And look at the coefficient. I have 1 mole of gas over here. So when I increase the pressure, what does that mean? I started out like this, big space. And then I increase the pressure, and I've got a little tiny space. So which one fits better? In the little space, the little number. So the equilibrium shifts to the right, to the product side. Okay. And then compare. Remember what I said about compare? It's either greater, less, or equal. So entropy, you had to remember, is disorder. So comparing the disorder of a gas to the disorder. So I'm comparing a gas to a liquid. Now, first of all, I'm comparing two different states of matter and two different temperatures. So higher temperature is going to have more disorder, particles moving faster. Also, state of matter, gas has more disorder. So the gas at 25 degrees Celsius has way more disorder. Okay. Finding the change in oxidation state. So if you look at the answer booklet for this question for number 61, it looks like this: from what to what. Okay, so I just need to know the oxidation number. This is an element alone. It will be 0. Right? This is an element combined with nitrate. Notice I have 2 nitrates. So if I go to table E, I will see that nitrate has a charge of -1, but I have 2 of them, -1, -1. So that totals -2. So it's going to have to be a +2 from copper to balance it. Now, 62, I can tell you this. The teachers and I, we disagreed about this and argued about this and hated it, because what I'm going to show you is the rating guide for number 62. Okay. So for number 62, okay, so it starts off fine because this says, based on table J, state why copper solid reacts spontaneously with Ag plus aqueous. Now, how most people have been trained in English, in history, in, I don't know, pretty much anything, when you have a written question, is rewrite the question and then answer it. Okay. But notice this: do not allow credit for copper is more active than Ag plus. Well, that's a bit rude, because the question literally says why copper reacts spontaneously with Ag plus. But they didn't want you to use the plus in your answer. They wanted you to realize that you're looking at table J, and table J only has elements. It does not list any charges. So they just wanted you to say that copper is more active, copper is higher, silver is less active, silver is lower, something like that. But you are not allowed to call it Ag plus. I think that's a bit rude. Okay, so just saying that, and there you go. Number 63 was kind of the hardest way I've seen them ask you to write a half reaction, because they gave the whole reaction here and the spectator ions are still present, and that's unusual. This one, number 64, I don't know, this tripped up a lot of people. A laboratory procedure. What a lot of people wrote was neutralization. And if I go to the rating guide for number 64, look at this: do not allow credit for neutralization. But if you knew what formula you had to use, look at what the, like, that's literally the name of the formula, is titration. So think about laboratory procedures. There's very few they're going to ask you about: evaporation, distillation, chromatography, maybe titration. Okay. Either separating a mixture or titration. Like, they're not going to ask a lot of procedure names. Okay. So 65 was just using that formula. This one was a silly way to lose points. So 3 of them that are metals. So you had a list of 5. Helium is a noble gas. And then you had to go to the reference table. here is tellurium right here. It's a metalloid. So tellurium is not. So it's the other three. Okay. Explain in terms of electrons. That means please say electrons in your answer. Here we have a compare. Literally greater, less than, equal. And remember, density values for elements are found right here in table S. Okay. This is a pretty 69 is a common question. 70. Again, this balancing, I was not a fan of it. Because if you put a 2 in front of this, first of all, we have oxygen in 2 places over here. Gross, awful. Second, if you start by putting a 2 here, that doesn't work. And then you try 3, that doesn't work. You have to use a 4 right here, and then everything will balance. Okay, but that was a little bit rude. Gram formula mass, that's fine. This was just mole ratio. It was a fine question. This is just memorization. They literally ask these ones so often. So for polarity of a carbon dioxide is nonpolar and water is polar. Like that, I don't know, that was kind of a gift. Even though you had to get both right in order to get the point. For number 76, strength of attraction for electrons. What the heck is strength of attraction for electrons? Well, that is electronegativity. So basically, you just had to look up electronegativity and which one was bigger, which one was smaller. Okay. For number 77, it was a weird way to ask the question, but both elements are non-metals. Okay, just like if it was like in terms of element classification, why is it ionic? One's a metal, one's a non-metal. Okay. For number 78, so many people got this wrong. Okay. Empirical formula is reducing it and then glucose. But it told you up here that plants in plants, when they grow, light energy is converted to chemical energy. The reaction produces glucose and oxygen. So this is the formula for glucose. You just had to reduce it. Okay. The product, that's an alcohol, simple OH. Unsaturated, easy question. Organic compound. So although organic compounds, almost exclusively also contain hydrogen, that is not what defines them as organic. That's carbon. And then this one, which one is most acidic? This was relatively easy, but pH scale, whatever number was closest to 0 is most acidic. And so you had to say the liquid. You couldn't have said 2.1. You had to say the name lemon juice. And then the color of the indicator, fair question. 84. Let's look at it. This was a pretty easy question. Why? Because base plus acid yields salt plus what? Base plus acid, acid plus base, it's water. Now, if you didn't know that, you could literally have gone through and counted. Okay, there's a K, there's a K. That's accounted for, and figure out what's missing. And then based on the pH values, compare, again, greater, less than, equal. I don't know. This exam had so many compare questions. To me, that made it super easy. Okay. Now, again, there were some questions that were a little like, I don't like the way they asked it. But in general, this was a pretty fair exam. That does not mean that it is easy. There is so much vocabulary. Obviously, I'm just used to the vocabulary, but there is a lot of vocabulary and there are a lot of reference tables to be familiar with. But if you know the reference tables, you'll do well. Okay. Review vocabulary. That's important though. If you don't review vocabulary, it's going to be problematic for you. Okay. Do we have any last minute questions? Otherwise, feel free to ask a question on this video and I will try and go back to it and answer it as I can. But I just want to do a quick recap again, talk about what I thought were the most problematic questions, address those, and, get any feedback from you. Yes, absolutely. 81 is a good score for sure. And this exam is challenging. Okay. So when we look at the conversion chart, 81 means you only lost, um, you had a raw score of 71. Okay. And so that is, you lost 14 of the points, and you were so close to mastery. So yes, I would say absolutely 81 is a good score, and you should feel pretty proud of yourself for getting that. Okay. If you want to try for mastery with an 81 and you want to retake it, you have a high chance of being able to get mastery, but that's just a personal choice. Any of my students who got an 81, I would be super proud of them. Okay. It's a challenging exam with a lot of vocabulary. Okay. Um, so again, if you have any more follow-up questions, I will definitely try to answer them. Here's my cat coming to say hi. Um, but otherwise, I will do some review before the August exam. I'll probably do two review sessions before the August exam for anyone who is retaking it then. Okay, just to allow students to prepare. I am also teaching summer school here, so it will help my students in summer school who are preparing for that exam as well. Okay, so again, ask questions if you have them. I hope you have a great rest of your night, and I will just post a comment about a discussion about when I will hold the next live reviews before the August Regents. Okay. So thanks a lot and have a great night.